Okay, so B is going to be very similar to A. I want to find the first term, I want to find the common ratio, and I want to find up to what value we're adding. So B is actually easier than A. So check this out. Again, how do I find my first term? Do you guys remember? Anyone remembers how to find the first term?
Plug it in the equation.
Yeah, plug in whatever value you have here, plug it into the equation.
Yeah.
So if k is minus 1, okay, I mean if k is 1, sorry, it's gonna be minus 4 raised to the first power. What's minus 4 raised to the first power?
Same.
It's minus 4. Yeah, so the first term is minus 4. So I've got my first term, it's minus 4. Now the second thing that I need, it's the common ratio. You guys remember how to find the common ratio in geometric sequences? The common ratio, it's whatever is inside of the it's whatever value it's being raised to a power. Whatever value is being raised to a power. So what's the value here that's being raised to a power? Negative 4. So negative 4 is my common ratio. Okay, this problem just happens that the first term and the common ratio are the same. Okay, so remember, whatever value it's being raised to a power, that is the common ratio. Okay, and the last thing, n, up to what value am I adding here? Yeah, it's the value on top that tells me up to what value I'm adding. So I'm adding up to the 9th term. And that's it. I have the 3 things that I need to use my equation. Okay, now here's the equation. You can see there's my common ratio, there's my n, and there's my a sub 1. So let me put all of the values into this equation here. So I'm going to get something that looks like this. The sum up to the 9th term is going to be equals to a sub 1, which is minus 4, that times 1 minus my common ratio raised to the n, which is 9, that divided by 1 minus my common ratio again. Notice that I put a parenthesis. Whenever I have values that are negative as the common ratio, I always put a parenthesis. It makes it easier to see, like simplifying this. Okay, so let's start simplifying this. Okay, so it's going to be minus 4 times, now that denominator is going to become 1 minus minus 4. What's 1 minus minus 4? On the bottom, on the denominator, what is 1 minus minus 4? What? 5. Thank you. It's 5, because minus minus 4, that becomes plus 4, and 1, that's going to be 5. Now on top, I have to put minus 4 into the calculator. Minus 4 raised to the 9th power. I know, but eventually I'll stop, don't worry. Minus 4 raised to the 9th power. It's a huge number, guys. I get minus 262,144. Okay, now that is just the minus 4 raised to the minus 9. Now notice that there's a minus outside of it, so it goes positive. So it's going to be 1 plus 262 144.
Wait, one?
Yeah, cause the one over here,
Oh, one plus?
1 plus, cause yeah, this became plus.
264, 262.
Joshua, Joshua, Joshua. A bit. So let me continue. Then this will simplify to 4 times. The top will become 262 145. Thank you. And all of that divided by 5. Now remember, guys, some of the tricks that I showed you yesterday? I didn't mention the trick about dividing by 5. Is the top divisible by 5, guys? Look at the top. Is the top divisible by 5? There's one way to know if a number is divisible by 5. If the number ends on either 0 or 5, then the number is divisible by 5. So guys, the top is divisible by 5. So if you want to do 262 145 divided by 5, it'll give you a whole number, which in this case it gave me 52,429. So minus 4 times 52,429. And well, I'm multiplying this by 4. I'm multiplying by minus 4, sorry. That times minus 4 gives me minus 209,716. So when you multiply by 4, this is our final answer. Can you guys see that? Sorry, I can't zoom in.
Why?
I don't know, it doesn't let me.
Doesn't let you or you don't know?
I think both. I don't know.
Just kidding.
But can you guys see the? Yeah, that's it. So that's it. That's yeah. You can see 9B was actually easier
Yeah.
than 9A. That's because like it was easier to find a sub 1 and the common ratio and also like simplifying this was easier than this one because the top one had a lot of fractions, so we had to simplify a lot of fractions, and then we had a complex fraction. We had like a fraction over a fraction, so we had to simplify all of that as well. So that's why 9A was like a little tougher. Okay. Okay. So let's go on now to 10. Number 10. So here's 10. It's 10, guys. Oh, it doesn't give us like 10A and 10B, but there's two problems, okay? So this is 10A and this is 10B. So it's asking us to compute the sum, each sum below. Give exact values, not decimal approximations. If the sum does not exist, then, well, it does not exist. Click on no sum. Alright, so there's a possibility that one of these may not exist, that the sum will not exist. So, for this one, guys, you need to be looking for two things. One, if you notice on the top, what do you notice that the sequence end with? What is it ending with?
Just 3 dots.
The 3 dots, the ellipses. And ends with the dot dot dot. That means that this sequence, this series, is going to keep adding forever and ever. When it ends on the 3 dots, it means that it keeps adding forever. That's that one. What about the bottom one? What do you notice about the bottom one? Up to what value am I adding?
Infinity.
I'm adding up to the infinity. Guys, both of these are series that are adding up to infinity. So that means that if you go back to your list of equations, remember, for finding the sum of geometric series, we have these two formulas. The first one is when we're adding up to a specific number, and the second one it's when we're adding up to infinity. So guys, for number 10, we're going to be using the second one. You can see here s sub infinity. You can barely see that, but that is s sub infinity. We're adding up to infinity for the second equation. So, and actually the how do you call it? This equation, you can see, is actually simpler than the first equation, and we only need two things. We need the first term and the common ratio, and that's it. We only need those two things. I'll talk about this second part over here a little later. Okay, let's do the first one. Let's find the first term and the common ratio. Guys, what's gonna be the first term of this? Well, a sub 1. It's gonna be this thing here. Well, the very first term that you have, which is 3 times minus 4 over 9. So that's the first term. Let me simplify it. Okay, this will become minus 4/3. If you simplify it, it becomes minus 4/3. Okay, so I just simplified it. So the first term is minus 4/3. How do I know? Well, the bottom 9, that's 3 times 3. So I just cancel the 3 on the top and a 3 on the bottom, and that gives me the minus 4 on the top and a positive 3 on the bottom. So let me rewrite this. I can write it as 3 times minus 4, and 9 I can write it as 3 times 3, right? So 3 from the top and a 3 from the bottom cancels out, leaves me with minus 4 over 3. So I just simplified that simplified it to minus 4/3. So that's my a sub 1. What about my common ratio? What's my common ratio here? Remember, the common ratio is the value that's being raised to a power. Over here, what's the value that's being raised to a power every time? What's the value being raised to a power? Somebody? What's the value being raised to a power every time? Huh? 3? 3 is not being raised to any power.
Oh, no, it's 4 over 9.
There's no ones in here.
2.
Well,
Negative 4 over 9.
what's the value being raised to a power?
3.
No, 3 is not.
Negative 4 over 9.
Negative 4 ninths. Okay, negative 4 ninths, it's the value being raised to a power every time. Like on every term, you see.
No, not that one.
Well,
No.
okay. So my common ratio is that minus 4 ninths. That cannot be simplified. So that's it. Again, we only need those two things. We need the first term, and we need our common ratio. So I got both of them now. I can use the equation now. Now, before I use the equation, let me talk about this second part over here. The common ratio has to be between 0 and 1. This is what this means, okay? So, this part of the equation, 0 less than r less than 1. Sorry, this is supposed to be the absolute value of r. I'm sorry. The absolute value of r has to be a value between 0 and 1. Okay? So the question here is 4 ninths between 0 and 1? Is it? You can double check if you put it in the calculator. If you put 4 divided by 9, It gives you 0.4444. Is 0.444 a value between 0 and 1? It is. Anything that's like 0 point something something something, that's a value between 0 and 1. Okay? So 0 point something something something, yes. So guys, this has a sum. Okay, this has a sum. Remember that there's the chance that we may have no sum. Well, I double check my common ratio, so this is going to have a sum. Alright, so let's see. My equation says that it's going to be the common ratio, so the infinite sum, S sub infinity, it's going to be equals to the first term minus 4/3 divided by 1 minus the common ratio, so 1 minus 4/9. Now I have to simplify this. I gotta simplify this. So be ready for the steps, guys. I know you will see a lot of steps here, but I'm just writing all of the steps, and pretty much everything that I'm doing, it's 7th grade math, 7th to 8th grade math. Okay, this is just adding fractions and subtracting. So this will become minus 4/3 over the 1, I'm going to rewrite it as 9/9 plus 4/9. If you have questions, you can stop me at any time. Don't wait for me to be done to then ask questions. If you can ask me right now. This will be equals to minus 4/3 over this will be 13/9. And then this is equals to the first fraction, minus 4/3 times the reciprocal of the fraction on the bottom. That'll be 9/13. And as I multiply these two fractions, I will get minus 36 divided by 39.
Is that 99?
Where?
Under
Negative 4/3. Oh yeah, 9. Yeah, 9/9. That's the one I wrote as 9/9, just so that I could have common denominators. So is 36 divisible by 3? It's not. Wait, is it divisible? Yeah, both of these are divisible by 3. You can simplify this.
You can add those two numbers together, or also tied.
Both of these are divisible by 3. They're not divisible by 9, but they're divisible by 3. So that'll give me minus 12 over 13. And that's the final answer. That's it. We finished. It was. I'm glad. 12 minus 12 over 13. And that's the actual answer, right, on the back? Minus 12 over 13. Good. Alright, the last one. The last one. So, what's the first term of this one? What's the first term? A sub 1 will be just plug in the 1 into j. That'll give me 4 times minus 3 raised to the first power. That is equals to minus 16. Minus 16 is my first term. What's my common ratio? My common ratio is whatever value is being raised to a power. What value is the value being raised to a power? Minus 3. Minus 3 is the value being raised to a power. Now here's the thing. We have to double check if this has a sum or not. How? The key to figure out how, it's up here. the common ratio has to be between 0 and 1. If it is between 0 and 1, then yes, it has a sum. If it's not between 0 and 1, then it doesn't have a sum. Is minus 3 between 0 and 1? It's not. It's the value being raised to a power. So minus 3 is the value raised to a power. 4 is not being raised to a power, that's just 4. But minus 3 is. So guys, unfortunately, we're done. It has no sum. Unfortunately, it has no sum. So we're done. That's the answer for that one. Alright. Yeah, let me stop recording because that's it.